Okay, now that we understand the power rating of a two winding transformer and the power rating of an auto transformer, let's try to solve some of these problems that I have here. Uh, let's read it together. Let me maybe increase a bit the thickness a bit. Okay, so it says an 11 kVA 220 110 volt 60 hertz two winding transformer is connected as a step down auto transformer. So it is always good to draw what you're given, right? So this is a step down auto transformer. So as a step down auto transformer, this will look something like this. And this is my output, right? And then they say that the secondary voltage is 110 volts. And just so you know, this is the two winding, and this is the series connection. This was 220 and this is 110 volts. So if this is connected as a step down transformer, then the high voltage will be the sum of these two. So it's going to be 220 times 110. So this one here is actually 220 volts. So by KVL, we can see that the high voltage, V high, which is the primary voltage of the auto transformer, is actually going to be equal to 330 volts. And like that, we have solved this problem. So determine the nominal voltage rating on the primary side. So on the primary side, now we have 330 volts, and then the output voltage is 110, and this voltage is what we also call VC, which is the common winding voltage, and this voltage here is what we call VSE, and that is our series voltage. Now, continuing, in the auto transformer of question number 1, determine the nominal power rating of the transformer. So you are given the power rating of the two winding. So the value given here is the two winding. So the two winding is 11 kVA. Now they're asking you for the nominal power rating of the auto transformer. So we have seen that S input output is equal to S winding times NSE plus NC divided by NSC. Now, what we also need to know is that the number of turns ratio, the turns ratio in voltage and in the number of turns is the same. So if I say NSC plus NC is the same as saying VSE plus VC. So that means I have SW, and then here I have VSE plus VC divided by VSE. Now, SW is 11 kilo, so I just write it as 11, and then VSE is 220, and VC is 110, so overall that's 330 divided by VSE, which is 220. So if we use our calculator, let me just take my calculator quickly. 11 times 330 over 220. So that's 11 times 330 divided by 220, and I'm getting 16.5. So my solution here is 16.5 kVA. In other words, it's 16,500 volt ampere. So this is the solution for question number 2. So this is S input output is 16.5 kVA or 16,500 volt ampere. Now they are asking us to find in the autotransformer of question number 1, determine the power transferred to the primary side to the secondary side by conduction. So there are two ways to solve this problem. We know that 11,000 kVA is what we call the two-winding power, which is also called the power that is transferred by induction. So the two-winding power is the power that is transferred by induction, which is 11 kVA. If we know that in an autotransformer, the power is transferred in two ways, so S input output is the same as the power that is transferred by conduction and the power that is transferred by induction. The power that is transferred by conduction, we do not know, and the power that is transferred by induction is what we call the SW. So if I just do a quick mathematics, yeah, and of course I know there's the power rating of the autotransformer, which is 16.5. So then I can say that S conduction is nothing but 16.5 minus 11, and that will give me 5.5 kVA, and that's my answer. The other way would be to find the current, and then after you find the current, you do all this mathematics. Or from this equation that we know here, SW times VSE over VSC plus VC over VSE, you know, if I split this up, I get that S input output is equal to SW plus SW times VC over VSE. So this power is the one that is transferred by induction, and this is the one that is transferred by conduction. So if I do SW, which is 11, times VC, which is 110, divided by VSC, which is 220, I should get the same power that is transferred by conduction. So let me test it. So let's do it together. 11 times VC, which is the common, which is 110, divided by VSE, which is 220. If I do that, I'm getting 5.5. So those are the two ways we can get the power that is transferred by conduction. Okay, so this is the question number 3. Okay, so the question number 4, we'll do it in the next video. Thank you.